We are given 4 new functions, and this time we're finding compositions of those functions. So f of g of 3 means f of g of 3. First, I need to find g of 3. So g of 3 is equal to 3 times 3 plus 2, which is 8. So I need to find f of 8, and this is 2 times 8 squared. So this is 64 times 2, and f of 8 is equal to 128. In 20, we're finding h of j of 12. So first, I need to find j of 12. So I have 6 over 12, which gives me 1/2. So I need to find h of 1/2. So this is 3 minus 4 times 1/2. 4 times 1/2 is 2. So I have 3 minus 2, which is equal to 1. In number 21, we're finding g of h of x. So I'm going to take h of x and substitute it into g of x for x. So this is g of 3 minus 4x. So this will be 3 times 3 minus 4x minus 2. And this is 9 minus 12x minus 2. So this becomes negative 12x plus 7. In number 22, I have h of g of x. So I'm going to take g of x and put it into h of x for x. So I have 3 minus 4 times 3x minus 2. This gives me 3 minus 12x plus 8. And that gives me negative 12x plus 11. In the next set of examples, you are finding f of g of x and stating its domain. So f of g of x means I take g of x and put it into f of x for x. So this is 2 times x squared minus 3x plus 2 minus 3. So f of g of x is 2x squared minus 6x plus 4 minus 3. And f of g of x is 2x squared minus 6x plus 1. The domain of this quadratic is going to be negative infinity to positive infinity, because the domain of the input function is infinite and the domain of the output function is also infinite. In number 24, when we find f of g of x, we have the square root of 3x plus 1. The domain of g of x is infinite. However, the domain of f of x is not. So we know that the domain of a radical function has to be greater than or equal to 0. So we take our radicand and we make it greater than or equal to 0. This gives me 3x is greater than or equal to negative 1, and x is greater than or equal to negative 1/3. So my domain has to be greater than or equal to negative 1/3. So the domain of this function is negative 1/3 to infinity. In number 25, when I find f of g of x, I have 1 over 3 over x minus 2. Well, if I make a common denominator on the bottom, then this becomes 1 over 3 over x minus 2x over x. So this is 1 over 3 minus 2x over x. When you flip and multiply by the divisor, this becomes x over 3 minus 2x. Well, first, my input function, my domain, x cannot be equal to 0. And then for this function, I can't be, if I take my denominator, 3 minus 2x, and set it equal to 0, then I have x cannot be equal to negative 3 halves. My domain will be negative infinity to negative 3 halves, negative 3 halves to 0, and 0 to infinity. And number 26, when we find f of g of x, we have the square root of x minus 5 squared plus 5. When you square a square root, the square root goes away, and I have x minus 5 plus 5. And this reduces to x. If this were just y equals x, then our domain would be infinite. However, our input function is a radical. And since our input function is a radical, x minus 5 has to be greater than or equal to 0. So x has to be greater than or equal to 5. So even though the identity function has an infinite domain, your domain of a composite function can only be defined for all of the values of x in the domain in the composite function that are also allowed in the domain of the input function. So since the input function has to be greater than or equal to 5, the domain of the resultant function has to also be greater than or equal to 5. So it's from 5 to infinity. In numbers 27 through 30, we're given f of x and h of x and asked to find g of x, such that h of x is a composition of f of x and g of x. So what you do is you look at h of x and you try to break it apart into the two functions that it comprises. So this is an exponential function of base 10. So I have 10 to the power of x. And in my exponent, I have a quadratic function, x squared minus 17. So if f of x is 10 to the power of x, then g of x has to be x squared minus 17, so that when I put g of x into f of x, it gives me h of x. Again, in number 28, if you look at h of x first, I have a square root function and a quadratic function that have been put together. So if f of x is my square root function, then that means my g of x had to have been my quadratic function. Again, if I look at h of x in number 29, I have a cubic function and a sine function. Well, if f of x is my cubic, then that means g of x had to have been my sine function. And finally, in number 30, well, f of g of x has to be equal to x plus 9. And I know that f of x is x squared plus 9. So I put something into that square that made it become x. Well, the only thing possible is that into this square, I had to have put a square root because it had to cancel itself out. So that means g of x had to be the square root of x.